We're going to talk about FTIR analysis. FTIR analysis is Fourier transform infrared spectroscopy. It's a molecular versus an atomic analysis, which means that we're going to look at the molecule and not at the individual atoms. It's qualitative versus quantitative. However, you can do quantitative analysis with it, but at laboratory testing, we simply do qualitative. The analysis is performed in absorbance. It can be converted to transmittance as well. If you look at the screen on the left, that spectra is in absorbance. The screen on the right is in transmittance. They're just inversions of each other. This is the infrared spectrometer. It has an infrared light source that is the baseline of the energy. And what happens is a sample is put into that light source, and then the absorbance of that sample is what is used to measure the bonds of the carbon atoms. FTIR analysis is handy to use for several different types of samples. We can have powdered samples, we can have solid samples, we can have thin film samples, and we can have liquid samples. There are several different ways to get the sample into the FTIR. One is using a potassium bromide along with a powdered sample. Screw it together and press it into a pellet, and then we put that pellet on the rack that will go into the light path, and we shine the light directly through there. Another way is with a thin film. If the sample is already thin, or it can be pressed into a thin film, we put it in this cassette, and then we put the cassette in the light path, and we read the analysis from that. We can also do Nujol, which is liquids. They're placed on sodium chloride plates. Put two of them together with the liquid between it and shine the light path through there. Put it in that holder, and we can measure that material in liquid form through the glass plates. Another sampling method is attenuated total reflectance, and that lets us put a solid sample on top of a crystal, and then we tighten down the clamp so that the solid sample is held in tight proximity to the crystal, and then the IR light is bounced off of that, and we sample the material in that method. The first thing that we're going to do when we do an analysis is gather a background spectra so that that can be subtracted from the spectra that we get, so that all we're seeing is the actual sample that's gathered. Once the background spectra is collected, then we're ready to do an analysis. This is attenuated total reflectance mode. We have a piece of material that is supposed to be polyethylene, and we're going to place that onto the spectrometer, tighten down the clamp, and then we'll begin to gather the spectra for that. As you can see, the spectra is being gathered, and from that spectra we'll then run it through our libraries so that we can determine what the material is. The spectrometer runs many scans at one time so that we get a good sampling of the material. Once it's done, then we will take it and compare it to our libraries so that we can see what the material is. The spectra has been transferred to our library program, and now we're going to search through the libraries to see what material the libraries come up with. Once we've run it through our library, the library has determined that the material is polyethylene. It comes up with the best match first and then decreasing percentage of matches down below, and the best match was polyethylene high density.